Hello and welcome everyone. Today we'll be talking about something which is at the very heart of AI in healthcare, data. You might have heard people saying that data is the new oil, but what that even means, let's break it down for you. Data is the very foundation of any AI system. Think of data as information which you organize. Usually it is in the form of tables like Excel sheets with rows and columns. In hospitals, there will be abundance of data in patient charts, lab results. Like this, you give a lot of inputs. So these inputs and outputs depends on how you want to use your AI model for. Let's say, for example, you want to predict the prices of the houses. You give some inputs like the size of the house, the number of the bedrooms, and the output will be a price. In healthcare, like that, you can input the vital signs, the lab parameters, and based on that, your AI model will predict the risk of sepsis. So data is flexible. You define your point A and your point B, like what data you want to collect. With same data, you can answer different questions. For example, given a budget, what is the size of house I can buy? Versus given the size, what is the price? So you can ask it different way, but the same data can be utilized to answer various types of questions. You can assess the risk of sepsis, the need for ventilator, the chances of recovery. The same data can be used for various purposes. So AI isn't just about just numbers. It's not that you only need to input numbers, then only you will get something. Images can also be done, especially in healthcare. For example, you might have heard that people are training the AI to spot pneumonia on chest X-ray. Here the input is an image and the output is labeled as whether pneumonia is present or not. Now, how does this happen? How does this anything take place? For that, you need to manually label, which is key and time consuming. To make this model, someone, usually a doctor or a radiologist, has to go through thousands of such images, label each image as whether having a pneumonia or not. Clearly, it's not a very glamorous job, but it's very essential part of the job. So you must understand the hard work that the humans need to do before we have this AI interpret anything. So behavioral data is valuable too. Data isn't just about measurements. It can also be for actions. For example, tracking how antibiotics are being prescribed by the doctors, how patients are responding to a new treatment. Data can also come from downloads and partnerships. You have freely available data sets. You can download your data from there also. Just make sure that you pay attention to the copyright issues, the licensing requirements. Only then you can use those data. Now, be aware of some very common mistakes that we do when we want to go ahead and collect data and make an AI model. What's the most important thing that we face is we don't have a perfect data. For example, I have certain amount of information about some things, but I wanted to collect say 50 variables. But I am at the current rate able to collect around 30 to 35 variables. I am not consistently able to collect the data which is complete, that is not 50. So I am missing around 15 to 20 variables in most of the patients. So if you spend years waiting for when you will reach that perfect, that is you will get that 50 data, it is very, very difficult. It is ever going to start. So don't spend your years waiting for perfect data before you start anything. Similarly, we won't wait, that is one factor, but then even if you're collecting, don't assume that just because you have a lot of data, it automatically becomes anything of value. No, that is also not the thing. What is the quality of the data that you have actually undertaken? What is the relevance to the context that you're saying? For example, if you're trying to detect sepsis and you detect something completely unrelated to sepsis, say for example sodium may not directly have an implication on sepsis. So if you have parameters which directly don't have an impact on the patient developing that outcome, then you will have problems with it. So data quality is everything. You must have heard the term that garbage in and garbage out. If the data is full of mistakes, your AI prediction will be too. So the type of data is very important. So here we need to understand a very, very critical aspect, that is structured and unstructured data. Most of the data that most of us collect is unstructured data. What is structured data? Structured data is neat stuff. You have tables, lab values, things that fit into each box. Each variable has been properly defined. Each number is properly defined. Then only it is called a structured data. Unstructured data is when you have multiple variables, you have different types of units which are being used, you have audio recordings, you have images, you have free text notes. For example, if your diagnosis is written in just words, it is difficult to analyze those things. So these are unstructured data. AI will have to use some different tricks to understand anything from it. Supervised learning works on both types, whether you are using the structured or the unstructured data. So once we have the overall idea regarding data, next we need to understand there are some key terms like machine learning. It's basically a software that learns to predict an outcome. So I'm giving 10 variables. It is and learning to predict whether my patient will develop sepsis or not. It is nothing big deal. It's just a software program. We tell that program to be machine learning. So it's a lot of inputs towards an output. What is data science? Digging through data to find out patterns. When we are trying to find any pattern in the data that we have collected, which gives us more insight. Probably there is something in the data which we previously thought was not related to sepsis, but since we have collected a lot of data, now we can see that maybe this particular variable has some correlation with the patient ultimately developing sepsis. Deep learning and neural network, these are fancy machine learning languages which are great with images and text, but essentially they're the same thing. They're softwares which are trying to predict or find something. So machine learning gives you a smart tools. Data science gives you the decision making basis. Deep learning and neural networks are inspired from the brain, but they're not necessarily analogy to the brain. They try to simulate the brain, but they are essentially mathematical models only. So these three fields, they overlap with each other. That is AI, machine learning, deep learning, data science. They are all interlinked, but they are not essentially the same thing. But for us, it is more or less these terms will be used interchangeably because we are not really hardcore math specialists. These terms can be used interchangeably for us. So effective AI depends on good data practices. So you need good AI team, good IT team, good data collection. Then only you will have the best outcome. Thank you for your patience.